Welcome to a new test and teardown video. Yes, we are continuing with homebrew electronics and also radio amateur related stuff. Look at this one. 80 channel FM transceiver. So I think everything is inside this box. And it is very, very special. Look at the channels for transmit and channels for receiver. So you can use this switch, I guess, to change between transmitter and receiver channels depending on if you're transmitting or receiving, I guess. Like this, right? Separate or receiver. So I think this has something to do with the channels. So are you transmitting on a simplex channel or a repeater with different transmit and receive frequency? I really look forward to figure that out. So that will be a transmit LED. We got squells, the audio frequency gain, tone. So that's probably one of those tones to open repeaters, right? And it's quite heavy. Let's look at the backside. So this is a PL259 antenna connector, microphone, PA relay, external power amplifier. So that will be a loudspeaker, right? And look at that, the old power mains connector, and that is from the 70s or 65 something, really old mains power connector. I mean, that is, so maybe this unit is mid 70s is what I guess before I even open it. So I think we should open it before we try and power it up, because we might need to be able to yeah, we need to see what is going on, right? So now we are inside. There was a bag with a fuse in here. So that is maybe a hint. Got two mains transformers. It is made really beautiful with the wires. I kind of like that. See all the wires here? There's no wire mess. It is quite nice. And we got the transmitter and the receiver switches here. They go to some, I think those will be counters for PLLs. And I think this is like a switch or like a connector we can pull up. So that will probably be the PLL in here. And here is a little note about the TX oscillator. There's a bad startup if it's not trimmed carefully. And here's something about ripple, different capacitors, and playing around with, I think, oh, that will be those capacitors. So this is a modification or some experiment. Yeah, we got 4 capacitors here in parallel. So there's definitely something here that is was a problem he was trying to improve. And that, see, here's this note. This is from 1985. So that is almost 40 years ago. And he was playing with this and trying to optimize the capacitors in this power supply. But of course, a lot of this is much older. What we see here, that's actually Storno modules from some of their VHF radio series. So that's probably some audio or something like that, FM detection or stuff like that. That will be some audio. That is an audio amplifier, right? And maybe there's a little Storno module in those as well. I think we should try and open this. Also, I see some radio modules down there. So that is also a half a radio or something, right? That is, we got some really cute BNC connectors, and those coax cables, they go, I don't know, to the relays here. And in this end, there's also a, okay, this is the whole bottom part is one big mega module. What radio is that? I can't remember that model. It is that big. I don't know yet, but I think we're gonna find out soon. I think we should just try and power this up and see if it blows the fuse. I'm a little bit worried when I find a fuse in a bag, and that one looks like it's blown. And those two fuses, they're new, so that is probably a hint. I promise to always video when I turn on stuff, so I think we're gonna do that as well. No kaboom. And here we go. Here goes nothing. Okay. 15 watts of idle. I see a red lamp. I don't see any RF output, but I of course didn't try and get on. Are we going to push this one? Obviously you need to be in transmit. No? Well. Of course I need to connect something to the microphone input. I will see if I can figure out what is transmit. I just connected a signal generator and adjusted the squelch. So there's something that's a little bit funny with this squelch. See if I go to the, it's like it's inverted. So this tells me a little bit about the age of this product. It is like this, since this is inverted, I mean, but anyway, squelch seems to be working. And so this is channel 11, and if I go to channel 12, see, we hear something. I just input a really weak signal into this, and channel 12 is 45064. So if I go to channel 13, no, it's not funny. Let's go to channel 11. Let's go one down instead, right? So where is it? About here, right? So that was channel 11, and then let's go to channel 10. So that is 145. It's channel 10. I mean, is that right? Maybe in the good old days, or maybe it was supposed to be 25 kilohertz, but it is just not. So I think the PLL, there is a frequency, the reference frequency per channel hop, that oscillator or that crystal is not correct for some reason, because of course you want to jump 25 kilohertz, but what if that was something that was invented later? Because this unit is probably pretty old. Oh, let's turn this off. Like that. Whew. Anyway, see, this is the power supply. It's actually like an entire power supply unit. So we've got all the diodes. It goes, and there's a big, powerful transistor here in the back. Oh, we have to be careful here. We got mains, right? And then we also got all the little regulators and stuff. And this is also a unit that was pulled out of another radio. So I think this is a reconstruction using all sorts of ready-made parts, or I mean most of this I can see is from Storno radios, but I think we need to look in here as well. Here we got the transmitter and the receiver oscillators. Let me see if I can get some more light. And I think this is the transmitter and the receiver oscillator mixer, because they mix down the frequencies to a much lower frequency that is used for the PLL, and this is the PLL. And then the PLL controls the oscillators back. So this is done because in the good old days, PLLs, they couldn't really compare directly on the transmitter frequency or the receiver frequency. This is way too fast. So you have to mix it down, and this is done in this mixing and filtering and stuff. And we can see we got the different inputs from the different, when you're doing transmit or receive, then it's probably changing the frequency just a little bit. And then that goes into the PLL, and that one is the 4044, and then we got all the different counters. And also in commercial radios, they didn't have a lot of channels, or they didn't even have channels, but they were programmed by cutting diodes or connecting diodes, so you could fix them to the transmit and the receive frequency you wanted, and then you're done. So they still contained this PL stuff, but here he just connected all the signals to all the possible frequency combinations, to all the diodes. You can see the tiny little diodes down here. And I even think I've seen this connector in Storno equipment as well. I actually also think AP radio, they were also using this kind of connector. I really want to see what is down under here. So I unscrewed this entire panel because I was hoping I could take it out. But it seems like it was actually initially designed using all the long wires here to be taken out. You can also see connectors here, and we've got connectors here. But then some stuff is soldered directly here, and actually quite a lot. So that means it is impossible to take this out, really. I think I need to desolder some of the wires around the connectors, and also down here, this is the volume pot. So yeah, this section was definitely the audio amp. No big surprise, it's just screaming audio amp. So, but I definitely want to have a look in here. How the heck do I do that? Oops. That can't be good. Where was that? There's maybe it can be here, it can be there, it can be anywhere, right? Was it here? I think I will go back on the first video and see if I can see where that one was located. It is getting difficult to pull out this board. I need to remove a little bit of wires, and I think this one is connected to that one with the resistor, and the red one was connected to that one, and this is the power supply wires. That's supposed to be quite easy to remember, and the blue one is ground. And where is that going? To the relay. Okay, and the black one here was definitely that relay, and that one goes here as well. So I think also we got a few wires down here for the squelch, and yeah, only one for the squelch. That's what I need to remember. And then there's a yellow one goes on top of that resistor. The TX LED is the green one, is a yellow wire, and that goes to that resistor. But the power LED is a yellow wire too, and that one goes via a resistor, but that is to the blue wire, and that blue wire is the one that was connected to that one, I think is ground. So maybe it's not. Maybe the blue one here is some trick. I don't know. That I need to measure. That is funny. That took a little while to get in there. There was quite a lot of screws all the way around. But we are in. And this is definitely an old professional Storno transmitter and receiver from our VHF bands, and it is made in a very, very flat and compact unit like this, and it's designed to be screwed directly to a heatsink. This is inside their very flat cabinets where you could open the lid, and then you get access to power supply and radio stuff on each side. So this is why each side was really, really nice and flat. So of course he was lucky to score one or repair one or however obtain one of these. Back in the 70s, of course, this was the thing to get. And yeah, this is the power amplifier. So this is the pre-driver and this is the output. It's not a lot of watts, like 5 or 10 watts or something like that. But that was what we had in the good old days, and that will be a little output filter. And in here, that will be the RX-TX relay. I think it's really, really beautiful. There's quite a lot of trimmers and stuff to poke around with. And here's the crystal filter and the mixer. So what I think they're doing is they got, of course, a 10.7 megahertz crystal filter, that's the normal, and then we got an oscillator here, and then this is another mixer that will give you 455 kilohertz, and then this is probably a 455 kilohertz filter, and all of this is also a filter for probably 455. It really looks like that. But this unit is sealed, and I really didn't want to break this just to see what is inside that box. But it got to be something like that, right? So now I will assemble everything so it works real nice again. Oh, those are really heavy. Oh, this is brass, tinned brass. How beautiful. And quite thick material as well. So after a reassembly of this nice unit, of course I flipped the wires to the squelch. So now this one is behaving more normal. And this is actually a classic noise squelch. And this is what we kind of used in the good old days. So it's not a level So that means if I give it, see, a little bit of signal, you can just barely hear. Okay, there's the tone, right? Let me crank up the squelch as much as possible and just give it a little bit more signal. I mean, this is just a tiny bit more, so that means you can't block somebody who's really weak. Just because it is a noise squelch, that means it's measuring the background noise, and if this level is too low, then it will enable the audio. So that's just how it works, and this is very common to old radios. I think we should try and play with the transmitter.
Let's try and hear if this thing can receive something. Over. Yeah, it works. Boodly.
Maybe I should also reveal the mystery about the blue wire, because the red one here is plus 16, and it doesn't really seem to go anywhere at all, right? We got rectifiers here, and they go here, and then what? Only the blue wire goes anywhere, and that one is minus 26. So what is the idea? I think this minus 26 is only handling the relays, or something like that. It goes in two directions here, either this one or that one. So in receive mode, it goes this way. I don't know. So where's this funny wire going? Something runs on negative 26 volts. What? How is that done? How is that possible? Okay, transmitter is also working. I figured it out. There's a signal here in the microphone connector. When I connect this, see, it transmit, and see, when I do that, it sends a little clickety all over the band. And this capacitor right here is the microphone input. When I touch this one, I get audio out in the air. But here's the funny thing. This system here is using the same frequency for transmit and receive, and also the same mix down to the two divider systems and the PLL. So that means when you want to transmit and receive on the same frequency, you need to put in channel 40 for transmit, that is 145 exactly, and receive channel 10, that is also 145 exactly. So I mean, it's a little bit difficult to use for someone who didn't design this, but I guess this was not the intention. But that is how it definitely is. I can see that on the analyzer. So also the tone key was a very good idea. However, it was never implemented. We don't have any wires on the tone key switch. So far so good. This thing really works, and you could actually communicate with somebody using this rig if you wanted to. So I think it's all about setting up the analyzer for the right kind of thing you want to show. So here's what I'm showing. This is channel 40, and look at the frequency here. We got like 3 zeros. It's only 600 hertz wrong, and that is amazing after 40 years, right? So this is yeah, the span is 250 kilohertz, and we got 10 of those lines, right? So that means 25 kilohertz per line. And this is channel 40, 41, 42, 43, 45, and so on. So it is indeed jumping exactly 25 kilohertz. So the reason why I didn't see that on the receiver, that is probably because of the generator I'm using is not clean, or the injection is not clean enough for the receiver here. So I hear some splat and stuff from side channels. But anyway, it seems to be working, right? I am a little bit worried about what you see down here. See? But it is 60 dB down, so it is actually legal. Because I think legal limits is actually 40 in band and 50 out band, right? When it comes to radio amateurs. Yeah, and it's a little bit under 10 watts, as we can see. So that is also good. So now I'm done playing with this, and I will pack it back together and call it a day. I glued the labels back on, so I think they're cute to keep there with the nice comments. I think this is actually quite a nice achievement. If this was your first build when you were like quite young and after your first education and started at a radio company and scored some radio modules and put it all back together and actually made a nice transceiver out of it for radio amateur. Nice chit chat with everybody. So this is very, very old.